Nice. Okay, let's do this.
All right, I'm recording. So ready. Everyone see? Okay.
Yeah.
Yeah, it's good. I feel like this one looks pretty simple. Just like N A's, M B's, or whatever.
It's really like it. All right, text. Bust out the
Oh yeah.
text editor.
Yes, sir.
All right. Where's the file? All right. Okay. So I guess it's like 3 substrings of a big string, right?
Yeah. Yeah.
Yeah.
And each of them can have their own amount.
Which one?
And then you put they each have N numbers.
Mhm.
I think they might get a little mad with that
Okay.
because
Sure.
like it's not the same for all of them.
Yeah. Okay.
Oh, good point. Yeah. Let me just say some number of A, B, and C. And then get rid of probably respectively. Or I guess, I don't know if that's worded great. Maybe just say 3 substrings A, B, and C of varying length.
Okay.
That might be a better way to put it. Because I think that still conveys it since we don't have like a number N to refer to or any sort of specific relationship between the lengths.
Mhm.
So
And then one thing you might want to add is that they all have to be greater than or equal to 1. Or like they can't be 0. Like that's
Right, yeah.
is length greater. Look good.
Yeah, it looks good.
All right, cool. Is that the only one for this
It
first
looks,
question? All right,
I'll pick up number 2 if you guys don't mind.
right.
no
Sounds
problem.
good.
Okay. Let me start screen recording. Oh, it says disabled.
Oh, my bad.
All
Always
good.
forget to enable that. There we go.
Sweet, thanks. All right. Prove the following bigger ambiguous. Please use J flap to draw both of the trees. Okay. Use the font animation. Okay, so we're just drawing the parse tree. It looks like. So let me start a new one. This is from a practice thing earlier.
I think we're gonna have to do, yeah, you have to do two different ones, two trees.
Okay.
Yeah.
Okay, so for this last A, and then A can go to. Oh,
I guess we're just gonna do string to start out with or something.
yeah.
A plus A.
I guess we just have a fourth child for just like epsilon or the identity. What is identity? Okay.
Mm-hmm.
All right. I'm gonna draw these up real quick. Okay, so okay, and then ID can lead to A, B, or C. Now it says we're proving it's unambiguous. What do we have to show in the tree?
In order to prove it's not ambiguous, we have to have like a sample string it can produce, and then create the parse tree using a left and right tree. Does that make sense? So we're not actually
Yes.
making the tree for the grammar.
Okay, so we're making a left and a rightmost one, is what you're saying?
For yeah, for a string we choose. For
Oh,
a
for any, oh,
whatever.
we can just pick a string. Okay.
Yeah, yeah.
Hmm.
So we
I
can
mean,
just do
we,
like A
huh?
plus B plus C. I don't know. Doesn't have to be too complicated, I think. And I think just using those three, we should be able to prove it's ambiguous.
Okay. We'll just put it up here just so we can remember what we're trying to do here. Okay, and so we're just trying to prove that we can do it with the right and the leftmost derivation. Okay.
And so, well, the point is that we're going to prove that using each of those, we'll get a different tree. It won't be the same.
Different trees.
Does that make sense?
I
Okay.
think so. So we're trying to say that we can get the same expression via different trees.
Right.
Okay. Okay, that makes sense. All right, well, using this one then, so we start here, we can go to A. Let's see, we have A plus. We could have this lead to B, I guess.
And then one more thing, sorry, for I guess you already got, but for the A can point to A plus A or ID, right?
Hmm. So how would I draw that then in the tree? Because wouldn't that be so
So
we
in
want
this case, if we're doing left, I think, so A points to A plus A,
mhm.
and then the left A points to another A plus A, and the right A points to C.
Oh, okay. Okay, I see what you're saying. Right, because now we're doing okay, I see. Thanks. So I probably just get rid of this ID then.
Mm-hmm.
Cool. Okay. Yeah, this part was just as weird to me.
Yeah.
A, so this can be A plus A, and then this will be our identity. Or we want this to be since this can point to yeah, okay. Oh, whatever. Yeah. Okay, so
Yeah.
A plus A, and then this one will be C.
And then each of those point to an ID. Oh, and then you'll have to have it point to an ID too, as well. The A's
Oh,
point to
right,
ID.
right. Okay, yeah, because A doesn't actually have those values. It has to be an ID. Okay, let's just change the label. Yeah, I think I get it now. Right, and then that's because our bottom, all the leaves have our actual expression. Oh no, there we go. I keep messing up my label. Please don't do anything like that.
Those are also IDs.
I knew that. That's new.
Should there be another plus in between those? It's like SAA, and then there's like the two A's.
Yeah.
Oh yeah.
Yes. You said SAA.
It'd be on right down
Written
there.
down.
Yeah. Nice.
Okay, so if we follow this down, then we have A plus B plus C. Yeah, that looks sufficient. Okay,
And
so now we
then
do.
you'll have to make
Huh?
another tree.
Yeah, I know. That's what I was saying. Now we do it rightmost.
Nice.
Okay. Here. So if we're going down the right expression, then here we'd want our A plus A. Okay, put 2 there.
Yeah. Oh dang.
Okay. Now here, this guy would become ID over here.
That would also be an A. Sorry. Because it's A points to A plus A.
And then there'd be another plus. Now ID.
Yeah.
Where's the hitbox? There we go. Okay, do we think I have to go back and fix these little arrows, the labels, or do you think they'll care?
I think that's probably fine.
Yeah, I think so too.
And then there's the A.
Yeah.
You forgot to put the lowest A on there. On the left where it says Q23.
Oh,
Yeah.
thanks.
Yeah.
Okay. A plus B plus C. Yep, and we can still get those from right and leftmost. Cool.
Yeah. Okay. I'll start screen sharing then.
Stop here. Thank you. Appreciate the help.
Yeah. Let's do this. Okay. The equation is given below. Create the right and left and rightmost iteration for the following grammar. And then there's the equation. Oh God. This is gonna be a lot. Okay. And it's the first one, right? Finite automaton.
Yes.
Okay. Okay. do this. So we're gonna start off with a sign. Oh gosh. Okay. Sign points to, okay, we're gonna have A on the left. So
it should have 3 children, right? It'll be var and then equals and then expression.
you're right, okay. And so this right side was pretty easy, I believe. Middle one is equal, and this one is express.
Mhm.
I thought it was funny in the class when he would, whoa, okay, you have to drag them. In the class when he would say exponent, because it was like shortened. How did you do this?
Oh, to get rid of the label, you do a spacebar enter. That was something he was talking about in the videos.
It's just
Yeah.
okay, thank you.
The UI is a little, it feels a little sticky. I don't know, it feels a little weird.
Okay.
All right, so
An expression.
is derivation like the tree, or is it like the like on page 16 of the notes, they have like a like written out
Oh,
where it like replaces all this.
I think
I think it.
I think you're right because we're doing leftmost and rightmost derivations, so we have to do each step. Yeah, because on the last one it said you use JFlop, right? You're so right. Okay, thank you.
Oh, I
Got
see.
a little-
Yeah, not doing a tree.
got a
Oh,
little-
it's even worse.
How should I do this? Oh gosh. Should I do it in?
Yeah, I think just doing a text editor and we can just copy paste. That's
Okay.
probably. I'm gonna pull up the notes on the. This part's ugly.
I think you just did. Okay, so one is a sign. Two is
Mhm. Are we doing leftmost first?
yes, that's what I'm doing right now.
Okay, I'm just gonna write that down just in case I forget. Oh, yeah, cool.
Leftmost. Okay. So four, we're going to factor because we're dividing. Okay. So A equals factor. Does that look good?
Yes.
Okay, then this one's gonna be div divided by factor. Okay, then our div is gonna be div points to statement, I believe. Then A equals, and statement points to minus minus var.
Since it's a leftmost derivation for your line 4, wouldn't it be factor times factor for the expression?
Factor times factor. Well, because in our actual equation, it's divided.
Oh,
Oh,
right.
because this is within the parentheses, so this just goes later,
Okay. Okay, I see. Okay.
I believe. Okay. A equals minus minus C, I believe, divided by factor. Then 9A equals minus C divided by factor points to div. God, this is the worst part.
Points to div.
Then div points to statement. Then statement points to parentheses expression.
Mhm.
Okay. Then
Expression points to, would it be just factor again? Or no?
if it's leftmost, do we have to go to the plus? How does that work? No, because we can't point, once we get to the plus, we can't then go back up to the multiplication.
Unless you're totally done with that.
Yeah, so I think unless you do another parenthesis, so then this one you have to do the multiplication. I think you're right. So factor times expression. A equals minus C divided by question mark. Then factor you want to get to the plus, so factor points to div. Expression 14a equals. Div points to statement plus div. Times expression. I think that's right.
Yeah.
And statement points to just var.
All right.
Div times expression. Okay. Var points to, of course, b plus div 16. Div points to statement. Okay. This is nice. I got to catch my mistakes. Okay. Then that points to plus plus var.
Right.
Oh, I messed it up. B plus 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 var expression. 19. Oh, this is so long. B plus 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 E times expression. Let me just, I'm done. Okay. Expression points to div.
Wait.
Is that wrong? It puts to factor. Yeah. And then to div. Okay. Then div points to statement. Statement points to var. And then this becomes D.
Man.
Yeah.
Let's do it all over again.
Right.
Let me just, I guess it's these two.
Yeah. Getting some var expression.
R equals factor. I can just kind of look at the other one. It's nice. 4.0.
And this should just be div? Question mark? Or wait,
Yeah,
oh,
because there's only one. There's only one thing you can. There's only one thing on the right side right now. So factor. Now to do the factor. Okay. R equals. I'm gonna copy and paste this. Okay. Okay. Div divided by. Then factor points to div, I believe, because we're trying to get to parentheses.
mhm.
Okay. 6.0. Div divided by div points to statement. Statement points to parentheses expression. And then inside expression points to factor times expression. Factor times expression points to factor as well. Factor points to div. Oh, whoops. Then div points to statement. Statement points to var. So finally, we have a D.
Go on.
Factor points to div.
And that would be statement plus div next.
Statement plus div. Okay. Statement plus statement.
Yeah. This would just be plus plus.
Bar.
Plus bar. Okay.
Just plus E, I guess.
Plus E. 19. Statement points to just var. Okay.
Ooh, yeah. Okay.
And this is just B plus A times D. Now it's getting better.
Yeah.
Stop doing that now. Okay, so var equals div points to statement. I believe. So we did up here.
Minus var. All right, there you go.
Yeah. Statement. Var equals minus var. The count isn't going to be the same. That's scaring me a little bit, right? No, it's never mind. It is going to be the same. I'm going crazy. Var equals minus C, then A equals C. Okay.
Nice.
Awesome.
Good, guys.
Yeah, looks good to me.
Okay, I'll stop sharing then.
I'm so glad we don't have to handwrite any of those.
Yeah, true.
Really suck. All right. I'll start sharing again. Oh. Tap.
So it looks like it's going to produce any string where A occurs the same amount of times as B or C. So
Okay. All right. I guess text editor.
Doesn't mean I guess so. Is it like A times I and then you just do A that many times?
I think
I
so.
think so, yeah.
Okay. Okay.
And I guess I and J are also greater than 0. I guess that applies.
Oh yeah, it's like I guess it's supposed to be a list, yeah.
Cool. Kind of weird. It's just negative. Negative amount of A. All right. Give some examples of the types of language. So we
A, B, C, C.
A, B, C, C. Nope.
The back.
A, C.
Maybe. Part A done.
One more.
Power hungry.
Wait.
All the strings.
2, 3, 4, 5, 6. All right.
All right. Context for camera.
Okay. So we've got start with S. S points to yes, P, right?
We could do it where it's like A plus B plus C, like it had in one of the previous questions. I think it was like the first one. Yeah. Yeah, the first one might be pretty actually similar.
I think
You might
so.
need
There
to
just
arrow.
aren't pluses. You just put the brackets.
Just no pluses.
Yeah, because
Yeah, no plus.
we're not doing stuff. It'll just combine them.
And then this is where it gets weird.
Okay, so it can be. Hmm. So
So A will need to point to B or to C somehow, I think. I mean, B or C must, like there has to be the or operator for sure, and
right.
B and C will be represented on both sides of that or. So
Okay.
we
So we can do like that.
uh
I don't know. Hmm. Oh, I guess would we use like I and J and stuff?
and maybe, but
I don't
actually,
think
what if we just
so.
wait, if you put back bracket B there, then whenever we make our B angle bracket, like on another line, we could just have at the end of it, like make sure you have an or that's just the letter A, so that once we've hit like the end of it, we can just push that letter, and then B will have the same way where B can just push A.
Okay.
Yeah.
Okay. Cool.
I don't know if that makes sense, but basically it's like we would almost, as long as they both are able to output. Let me think how to word that. I'm gonna write it down.
But then it needs to be in order. That's
Yeah, in terms of like which one is called which. Yeah.
well, it's like A needs to be at the beginning, then B, then C.
Right.
Oh, you're talking about for
Because in other examples,
let me see.
well, I mean, like on the one we're doing right now, it's like I think that's what to do. It has to be like a block of A's, then the block of, like how we had it in the example. And so I don't know how, but I don't know how we do that with the language.
So in this first one, it did like A and then so it's like A or like another called A or just one A to end it. So could we do like okay. So what if it was A or
It's like every time we call A, it has to print an A and a B.
or an A and a C? Okay. Oh, well, I guess not.
Yeah, if the order matters, that's where it gets weird. I think that yeah, just make sure that if B can output an A, that would be good, because that way you could just continuously go back to B, and even though you're on the B node, you can still print out the letter A.
Right. Okay. So you mean A like lowercase a or like A like
Lowercase a, yeah, output
okay.
A. Yeah. So have another or. We can just leave it that way. I'm sure we could optimize it, but this way, at least right now,
I guess it would be
you call back
B,
name.
C, or C.
Should on the B node again, the output that has the lowercase a, should that also have a capital A next to it? So that way, as many times as we need to, we can keep feedbacking in. Because if we have the terminal A here, then we're done. So if you were to follow this, then you'd say, okay, we have node A, and node A calls B, and then it goes down to B and prints A. So we only get one A anyways. If we put the bracket A right where your cursor is, or right where your little insert thing is, then it can keep going back as many times as we need to.
Okay. Let me grab a charger. My computer's about to die.
Okay.
Give me just a second.
I think I might have an idea.
Okay.
I think the whole like angle bracket ABC thing might be like
Mhm.
a red herring, because then that just trips up the whole thing. I think instead we just need two of them, and then once for either case. Once for the case where A and B are the same amount, and once for the case where A and C are the same amount.
Oh. Huh. Okay.
And then in each one of those, like if it was the first one, it'd just be A, B, A, B, and then you can have optional C's. And for a second one, it's A, C, A, C, and then you can have the optional B's in the middle.
I see. Okay. The first one we've got let's see, A. Okay.
Let's start with a terminal. Just make life easier so that we know we have some constants. Just have a terminal. Or well, no, now because A and B don't represent the actual A and B values, they represent case 1, case 2. Okay, so
Mhm.
case 1 is A and C or A and B match. Let's just say that, and B is
I think for that case, we output A, B, C, or C.
Okay.
Does that make sense? And then these case names are confusing though.
Yeah, can we make it like X and Y or something agnostic to? I mean, it could even be like AB if you want, or something. Just to I don't know. Yeah, this is
I think that works.
Okay. So this first one should just be
I think just A, B, and then brackets C. And then or C after that. Yeah,
bracket brackets Y.
for
Is
this
there
one be C. Because why is the case where we have A and C the same amount? But in this one, it doesn't matter how many C's there are.
okay.
this will break the order though. I mean, we'll have like ABC, possible type things. So if we're fine with breaking the order, then that's fine. But I think that might be part of the problem statement, like we talked about earlier. It has to be a block of A, then a block of B. I mean, by definition, if you look at X right now, then we'll print A and B. So
Oh, I see what you're saying.
yeah,
So
so
then
we
put X between A and B. Yeah.
yeah.
So then does that.
Are we allowed to have this like C call if we don't have?
Yeah. Yeah, we
Okay.
are.
Cool. Cool. All right.
And the option is if we want no A's or B's, we just put C there. The bracket C.
Yeah.
Did it say that? Oh wait, this is question 1. There we go.
As long as bracket C gets defined, it doesn't matter.
And then bracket C either just points to C or a null character.
Yeah. Okay.
So that seems robust in printing out our C. Are we going to do the same thing for an A value? Because right now we only print one lowercase a. So I guess that would be Y's position.
Sorry, what do you say?
I'm saying that as we've got it so far, how are we going to duplicate A? Like if we wanted 3 A's and 3 C's, how do we get the 3 A's?
So for Y, we're going to do the same thing. It's what's going to be a different order. It'll be. Now I am realizing it. This is.
I think that's not quite what I mean is like, okay, so as I interpret it here, our X represents the case such that pick whichever A and B or A and C, but 2 of them match and B doesn't, right? And match, you get it. X and Y represent the 2 realistic cases that we have with the problem statement. So wouldn't we use those independently then? So like Y and X shouldn't really mingle since.
Yeah, no, exactly.
Yeah. And so, okay, so given that, if we go down the route of X, what I'm asking more is like, okay, so suppose we want to make the string where it's 3 A's, 3 B's, and 1 C. How are we going to keep getting multiple A's? Because right now, I think what we might need is for the X output, we might need an optional terminal for A and B, like just the lowercase output. Otherwise, I see no way to get multiple A's because right now, if you follow.
Oh, okay. I understand what you're saying. Okay, yeah, then just A B.
That way you can keep.
Yeah.
Okay.
Well, without the thing in between them. And I think I also just realized that So if we had this, A, X, B, C, if we went inside that, there could be a C like within that. If that makes sense? There could be C's between A and B if we went there. So I think X, I think we have to do another.
Quick question.
So
Quick question.
yeah.
Why do we delete the or between A and B? Because I think that we need that because we're trying to preserve the order of blocks of A, then blocks of B, blocks of C, and that would override that. And also, the idea there is that we can cyclically keep pumping A's. We can keep pushing in the stack if you think of it that way. If we have block A space B, then we've limited ourselves where we can never have 3, 4, 5, 6, greater than 2 essentially A's because we've then terminated that A block there. Does that
So
kind of
you're
make sense?
saying, get rid of the and, get rid of the or have the or.
Keep the or, keep the or.
Keep it.
But then in the case where it's an or, we could have differing amounts of A and B. Because this is for the case where A and B are there the same amount of times.
That's true. However, we do need a case. I mean, maybe we can have a separate one if we want, where it's like A, B. But the thing is that I think that we are trusting whoever's using the language to then.
But that's not how the language works, though.
Yeah,
If it's possible, then it won't work. So if they want to go the other option, they have to go down the Y branch.
This approach with the XY may not be good then, because what we've got is if you did the A, B, right? Like I'm good with you on there being equal. I don't think that's how to do it though, because then that would have to be the absolute terminal where that A space B represents the end of the A and then the start of the B. That's an incredibly niche case that could probably be solved with more modular logic. That's also, I think the A or B should stay. If we have like another case, maybe that'd be fine. But I think that for sure we need that. I don't know where A space B would.
Well, there wouldn't be a space between A and B. It would just be A, B right next to each other. What do you?
No, but are we keeping an order where it's blocks of A, then blocks of B, then blocks of C?
Yeah.
So if we had an output where it's just A and B, that would only be used in a transitional period, right? Where we're going from a block of A to a block of B, right? Because then you'll have A, B, A, B otherwise.
Well, in this one, because X is between them, it'd be A, A, B, B.
Let me see here. Okay.
It's not, it wouldn't be A, B, then X.
Okay, I think I see what you're saying. Yeah, we can give that a go. Okay, yeah, because then we would keep it, since it's expanding from the middle.
Yeah, you put more ABs in the middle of that.
Okay, I see.
And so then the other problem I was saying is that because we have the C at the end of X, it could put C's in between A and B. And so I think we need to have the case where X points to the case where A and B are the same amount. And then within that, we need to have two cases. One's like the recursive case for A's and B's, and one is the C's at the end. So I think X then needs to point to like two cases instead.
Okay.
Does that make sense? Sorry, I know this is a lot all over. But I think X only needs to point to like two more states that we make at the same time.
Okay. So we need two more over at the end.
Like that's all X points to. Sorry, I know I'm like flipping this whole thing up.
Oh, that makes sense. That makes sense. That way there's no random C's that just pop up.
Yeah. So then X would just point to two new states that we have to make.
Okay.
So
call them, I don't know.
Yeah. And then so D is the one that points to ADB with the lowercase a, then the D, then the lowercase b. And then E points to
just C.
Yeah.
C. We need,
and I think D would also point to just null.
Just null?
Yeah.
Do we not this like the expanding thing anymore?
I don't think we need the AB on that one, because if we got into the inner D, it would just point to null and be fine.
True. Okay. Yeah, that's about it. Yeah.
Cool.
And then E would just point to C or like lowercase c, C or C or null. Oh gosh.
It is getting a little, yeah.
Or actually, it would just be lowercase c, big C, and then or null. Yeah.
Would we even need the lower? Yeah, okay, yeah. I don't think we even need the lowercase c because that null termination.
Yeah, exactly.
Yeah, looks
And
good.
so now we're good. So we can just start.
Okay.
Yeah.
There's our
Oh,
first.
sorry. Sorry. E should point to itself. So C, E.
So yeah, so we can go
I
E.
see. Got it.
That's it too.
And then we just do the same thing for that one with the orders.
Cool.
I don't think C needs to exist, does it?
Yeah, maybe not. Maybe
Yeah,
we
I
should
don't think it needs to exist either.
change E to C. It might make more sense.
Okay.
Sure. By C or the other guy. There we go.
So then in our Y case, oh, I just realized in S it should be X or Y on the top. On S, sorry.
Oh my goodness.
Yeah, right. Because we're only doing one.
Yeah. One or the other.
So one
So
all
then,
the string.
yeah. And then
So
I don't think this one has to be different because it's A, C, and then B's in the middle.
Okay.
Yeah. So this one might have to go back to our original where let me see.
I think we might just do A, then a state, then C.
Okay.
I think it'd be A, Y, C. Like as in the lowercase a and C.
Oh, okay. I see what you mean.
Y, C. And then or
AC
This could
or
see
or B and then or null.
Yeah, no. We'd also, yeah.
when you need
No,
another
we need to call to another
or
state.
AC, so it can.
I think it'd be need to
Not
be
AC.
BY.
Yeah.
BY.
Yeah. I guess or.
So then it could fill in all those ACs and then do the BY and then point to null. Oh wait, actually, no, it can't point back to itself because then we could have
Just infinitely.
C's and stuff. I think that would have to be a different one once again.
Okay.
It'd be B and some other variable. Like lowercase b, it points to, oh yeah, I get, never mind, that works, yeah, sorry. And then b just points to
B or null.
BB or null.
Let's see. See if this works. Try this first one.
So the first one we choose y. You have to.
A.
We'll go back to Y, make another AC. Then we
I
choose
think
B.
in y we can get rid of the first lowercase b, that state.
Okay, that looks like it works for the first one at least. Cool.
Is the grammar ambiguous? Oh god.
A draw.
I think it would be. If so, draw two different parse trees for expression ABC. I don't think it shouldn't take too long. And we have a lot of time left, right, Oliver?
Yeah. Yeah, we got 40 minutes. Okay.
Okay.
Let me save this real quick.
So you have to do a left and a rightmost for X and Y, right? Since they're two separate, or no? No, never mind.
Okay.
So the string is AABBCC, I think.
Yeah. Okay. Let me rearrange my windows. All right, here we go. So Okay, so we got.
So if we're gonna do leftmost,
Mhm.
that means you point to X, I guess. You just directly point to X.
Yeah.
I guess it makes sense that this one's ambiguous because we can choose either option. We can go either the X way or the Y way.
Mhm.
All right, so then X, we got D, C. Okay.
And then
D points to A.
then D points to A, D, B.
AD. Okay, so that would be
Yeah,
like three. We got
there'd be
like
3 there.
ADB and then or no.
Yeah, that looks good.
Wait. Okay, let me start. Okay.
And then the other D just does the same thing again.
Okay. I'll worry about the connectors in a second. All right.
Mm.
Oh, okay. Why are they all labeled with lambda?
You have to do space enter.
Ah,
I doubt they'll care, honestly.
fix it real quick. Okay. So we got A, B, C, C, right?
And then that last D points to null.
Keep doing it. Okay. On this side.
And then C just points to lowercase c, big C. And then the C points to null, on the right. That's it. Oh wait, no it doesn't, because we need 2 C's. My bad.
Yeah. Okay. Then this one's so close together. This would be no, right?
And then the one of the C's points to, that one points also to C, yeah. And then we need the other tree, yeah.
All right. Okay. Let me. Move that a little bit. Okay, cool. Second tree. We got S. I'm gonna point to Y, which then we got A, Y, C, or B, no. A, guess that's A terminal. Y. So we would need this Y to point to another AYC, right?
Yes. Wait, is this gonna work for Y? Because if you were to even just right now, if you kind of look at the leaves, it's gonna read ACCBB.
Hmm.
Or
What are you
Y
saying?
logic.
Oh,
You
yeah,
just like
for the Y one, we have, it's gonna be like a big tree that's gonna point down and it's do all the ACs, and then at the end it's gonna do two of the Bs.
Okay.
So you have to do, I guess, like the two for the ACs, and then after that is the two for the Bs.
Yeah. Okay.
Then AYC, and then B. It would point to B, just one, the bracket B, and underneath that point to BB, and then BB again, and then no. Yeah, that's good.
Oh wait, why is it not? All right.
Oh, 30. Okay, I thought that was like a 5-minute warning.
No,
Oh my God, how long have we doing trees?
I can't seem to move this thing. Doesn't want to let me, but I can move this one this way. Oh, all right. Well, okay, cool.
Nice.
That's good. So I guess I'll say yes. All right, cool.
Very nice. All right, I'll go
Nice.
for the last one. All right, so rewrite do we know what BNF means, anyone?
I don't remember what it stands for, but it's like that like different way of like describing it, I think.
BNF.
Yeah, I don't remember what that means, but I mean, I think I understand the rest of it. Give plus precedence over star. So plus addition comes before multiplication, and then force to be right associative. Use the notes as an example. Test transfer Q5 answer. Okay, so if I were to make it right associative, I would just switch expression and term here. But if I wanted to put plus higher precedence than multiplication, I know that the plus would need to be lower down here. But does that mean that I would just copy paste this whole term? Because I thought he said that it doesn't matter which block goes first as long as the expressions are congruent.
I feel like if you just switch plus and times that works, right? Just the characters.
Yeah, that's what I was thinking too. But then what about factor? Like, how does that?
I guess it's just like a word though. I don't know. I guess you could switch them.
And then
Just-
factor, it's just that factor gets. I don't know. That's weird. I feel like that might break it.
I think the words might be weird, but it would work though.
Yeah, with the expression.
It would add things and then multiply them.
Okay, yeah. So I'll just switch the symbol and then the order of term and expression, or whatever it was. Too many tabs. Text. All right. So, oh man, hold on. It's showing my private notes here. Hold on one second. How do you hide this? What did you use for your text editor, Oliver, since you're on Mac as well?
I just look text edit, yeah.
Oh, okay, good deal. What?
There's a button for new document in there.
Oh, for real?
I think, yeah, just make it
Yeah,
to the bottom left.
Okay, cool. Thank you. Okay. Copy paste. That looks terrible. I mean, that looks. Yep, that's right associative, and then. Okay, so just drop. Is that really it? That seems too.
And then you also have to do the tree, but I think so, yeah.
Yeah, I know the tree is just that. Okay. The tree's the hard part, I guess.
So doesn't look too complicated of a.
Just this question 5, I assumed it would be like a Navy SEAL of a question, but whatever. All right. Maybe I text it. Okay, so we can start with a sign, and that goes to ID equals expression. Space these out a little better. Okay, sign ID equals expression. And what are we trying to get again?
B plus C times A.
Okay, so we want plus at the top here. Okay, so expression goes to that, or term goes to that plus factor. So this will become our B. I can just start with that here. Oh wait, never mind. That's our A. Oops. So if we want, wait, if it takes precedence, then times is at the top, right? It goes times and then plus? No. Yeah. Yeah.
Yeah, otherwise there'll be parentheses. Yeah.
Yeah, because then it'd be
But then on that note, it would be expression though.
oh, right here.
And then that points to it.
Right. And that points to multiplication. Okay. We're going term by expression. Term is that.
Term points to
Timmer. Okay. So be C times. Oh, that's weird. Okay, so this will become B plus C.
yeah.
Should probably start doing this. Okay, so B plus C. That'd be ID, and this would be plus. Or no, term.
It would point to term on the left side. Yeah.
Yeah, it'd be term, and then from there,
yeah.
I guess factor, and then be factor. Oh, that's weird because then it goes factor, and then factor goes to the expression. Oh, or ID. Oh, okay, we're fine. Okay. Wait, wouldn't it just be better to just have them both as factor actually? Because at this point we're gonna just get two terms here. It's gonna get B plus C.
Well, that's what we want.
Wait, am I tripping? Yeah, okay.
That's
So
exactly what we want.
yeah, I just wrote it wrong.
Are we able to do two factors coming from term, or do we have to do like a second term that points to like a factor?
Oh, maybe that's what you mean.
I think we should like term points like term plus factor, and then the first term points to factor, which points to B, or what is it, B? C, whichever.
Yeah. So just basically one of them points a term, points a factor.
Mm-hmm.
Sure. Factor. Thank you.
And Oliver, I already emailed my question to you.
Oh, awesome. I'll load it into the
term.
Wait.
Oh, the factors then point to IDs. Aye. Too much, man. Too much.
It's just so redundant. It's killing me. All right. Sorry about that. Oh, that's not the right one. That's the factor. Okay. World's longest tree, truthfully. It's so silly.
Imagine the trees they like actually use for like our programs. Oh my gosh.
Oh, geez. Yeah. Okay. Good point. I'm not going to complain here. Good point.
Oh god.
Could be worse. Is it really?
A
Times A.
let's see. Times A. Nice.
Expression goes to term. Term goes to factor, goes to ID, goes to A. Cool.
On the right side of expression, it points to expression. You just renamed it, but it should still be expression. Does that make sense?
Oh, right, because you can't. Yeah, we talked about that. Okay. Okay, expression points to term. Points to factor. Points to ID. Points to A.
Let's go.
Yay.
Awesome.
Okay, so A equals B times. Oh, so never mind. A equals B plus C times A. Oh, that didn't even read right, but it works. That's it.
It works. All right.
Cool.
Awesome.
All right,
Andres, I
listen,
got yours. It's on the quiz. So
what'd you say?
I was just telling that I got Andres's.
All right.
Fine.
Awesome.
All right, yeah, I'll email them to you. Do you want the JFlap file or just a PNG of it for question 5?
They said PNG.
Yeah,
In the quiz, they said
PNG.
PNG.
All right.
Yeah.
And then for the question I did earlier on was JFlap. I guess that's also an image, I'm assuming.
Mhm.
Yeah. Yeah.
Okay, yeah, two PNGs. Okay, yeah, I'll have those emailed to you right now, real quick, before we get off.
Actually, got to convert mine to PNG. Thank y'all for reminding.
There's always a good day when we don't have to submit within the last 5 seconds of that.
Oh yeah. Yeah. This is nice.
Yeah.
And we don't have the code either. That's nice.
Even less to submit. Yeah, true. Life's good.
Yeah.
How do you convert from the JFOP file to PNG?
I just literally screenshotted it.
Okay. Good set.
Trying to find my dang files though. All right, I just mailed it to you. Let me know if you've gotten it.
Awesome. Got it.
Awesome. Yeah, I also attached in there. The first one should be for question 5, second for 2.
Okay.
All right, good deal.
Alrighty.
It's good.
All right, yeah, good work, guys.
Thank you.
Yeah.
Thanks, guys. Have a good week.
That's it.
You too. So.
See ya.